So hi everyone, how you guys doing? First of all, let me welcome you guys to the Unacademy JEE English. This, as you know, is a brand new channel by Unacademy, which is India's largest online learning platform for IIT JEE. And at this particular channel of Unacademy, every concept of physics, chemistry, and maths are being taught to you completely in English. Now, this is a special series that I host every Saturday, and here we discuss Olympiad level problems and other advanced level problems, mostly from the book Pathfinder. So a lot of you were looking for solutions of the book Pathfinder, and that is why I have started hosting this series. So before we get started with today's session, let me introduce myself for those of you who might not know me yet. So my name is Rohit Dixit and I studied mechanical engineering from IIT Delhi. And for almost past 8 years now, I've been teaching physics for IIT JEE exams, both mains and advanced. So for 7 years, I had taught at offline setups, some of the most reputed ones that you know of. And from past 1 year, I've been teaching online here. Now, in my own JEE exam, I was All India rank 447 and All India rank 192 in the two stages that I had to go through. Now, I also qualified the NTSC Stage 2 as a student, and I was in the top 1% in the NSCP exam as well. I've already coached many students to top ranks in the IITJ exams, both mains, advanced, and various other exams as NSCP, etc., KVPY. And now I hope to continue doing that here with you guys. Now, students who are worried about how they can prepare in this period where they hardly have access to teachers, let alone good teachers. So you have a wonderful opportunity with the help of Unacademy subscription. So you guys can go for the Unacademy subscription. This subscription will give you benefits like live classes where you get to interact with your educators on a regular basis. And of course, you have live polls and leaderboards in these classrooms, which keep these classrooms highly interactive and quite efficient. Then you have test series and analysis sessions on a regular basis, which again keep you aware of the competition and you're standing there and where you need to focus more. And of course, you have live doubt clearing sessions. So every fourth session in all the Unacademy Plus courses is supposed to be a live doubt clearing session. So after every 3 teaching sessions, you have one entire dedicated session towards doubt clearing where a student can ask all their doubts about their theory, their concepts, or problem solving difficulties that they are facing. Now, apart from all these benefits, the biggest opportunity that you're getting with the Unacademy subscription is the chance to study from the topmost educators all across the country from the comfort and safety of your home. So that's a huge opportunity, which I think no student should miss out on. So how do you get these benefits and avail these opportunities? So the first step involves for you to install the Unacademy app. The moment you install that, you will unlock for yourself a lot of features like free courses. Okay, and then you have something called special classes. So for attending all these, all you need to do is just install the Unacademy app, and then you have quizzes. So you will realize the moment you install this app, that is it. You can start using all these features. No subscription needed for these features. Okay, all you need to do is uh, use the welcome code RD Live, and that will unlock all these free features for you. Okay, so install the app, use this code, and you would start with your studies without any other thing. Okay. Now, so this will give you a flavor of how your Plus subscription is going to be and how your preparation with the Plus subscription is going to be. Now, if you like that and once you feel that you want to take your preparation to the next level, then that is when you can go for the Plus subscription. Okay. Now, the Plus subscription can be gotten as follows by following these steps. So first, you'll need to go to the Plus section of your app, an Academy app, then go to the IIT section, select your goal as IIT and click on that get subscription button. Okay, as simple as that. The moment you follow these 3 steps, you will be redirected to the payment page where you will find a box which will say, do you have a code? So that is where you can enter this code RD Live. So this code will give you a 10% off on all your subscription fees for both your Plus subscription or your Iconic subscription. And you will also realize when you click on proceed to pay, you will get a lot of no cost EMI options to break these payments into. Okay, so now those of you who don't know really what the Plus subscription is, so let me just quickly tell you about that. Plus subscription is something that will take your IIT preparation to the next level by allotting you personal coaches. So from our team of experts, you will be allotted personal coaches. These personal coaches will mentor you and guide you throughout your IIT journey very closely. And apart from other plus benefits, you also get to attend a lot of IIT workshops, receive expert guidelines from time to time, get a study planner, and get regular test analysis sessions. So with all these benefits, I think you will power through your IIT JEE journey and definitely achieve those dream ranks and dream colleges. Now, students who have just entered class 11th and are wondering what to do about their studies can go for one of the combo subscriptions that Unacademy has to offer now. Now, the combo subscriptions will take care of all your study needs, be it your class 11 CBSE, be it your class 12 CBSE, be it your class JEE Mains examination, be it your JEE Advanced examination. So the combos, there are four combos that you can choose from. The first combo offers you the iconic subscription for IIT and plus for the CBSE 11th and 12th. This combo starts at 4,600 a month. Then the second combo that you can choose from offers you iconic subscription for all three. And this combo starts at 5,500 a month. Third combo, of course, offers you the plus subscription for all three. And this combo starts at 3,000 a month. Finally, you have a combo which offers you plus subscription for JEE and the iconic subscription for CBSE 11th and 12th. And this combo starts at 3,900 a month. So again, you can choose a combo that suits your study needs and then leave all the worries of your studies behind. Now, these are the list of upcoming tests in January. So only one test is left now, I think. So Unacademy Combat, make sure you're taking part in that tomorrow live, and you can enroll now using the code RD Live. Okay. So don't forget to take part in this test. If you do well, you stand a chance to win for yourself a lot of cool prizes. All right, the students who are following us on this channel of Unacademy, which is Unacademy JEE English, do not forget to connect with us on the Telegram app using this link. So this will ensure that you're getting all the timely notifications and all the relevant informations and everything that this channel has to offer. So finally, let's get started with today's discussion of the Olympiad level problems. Okay, so today we'll be talking about problems from the chapter current electricity or electric current. So this is the first problem that I have for you. This is a very standard kind of a situation. I'm sure you must have seen this. So a closed cubical box is made up of a thin conducting sheet. Okay, when its diagonals are diagonally opposite corners are connected to a battery, it draws a current I from the battery. Now find the current flowing across the edge BE. What would be the current in this edge? Here, what is the current? That is what you need to find out. Okay, so give it a try and let me know your answers. And let's see if you can figure it out. Okay, see. Again, hint is you can use symmetry. Use symmetry and you should be fine. Okay. So think about it. Take some time and try and answer this. Okay. Total current crossing the edge that is to be found and should be the. Let's see, even if this is a solid cubical box made up of thin conducting sheets, you can still use the arguments of symmetry. You can realize whatever current enters through here, it will divide into three phases. Okay, this one, and this one, and the bottom one. Okay, and the current dividing into these would be I by 3 each, right? And all of it has to cross to the other side. So it has these methods of crossing it. So again, it will be very similar to if this was a cube connected by simple conductors only. So the total current that will have to cross this edge would be in fact I by 6. Okay, total I by 3 current will flow through each side, and out of which half of the current is going to cross from here, half the current is going to cross here, rest from here, rest from here. So it has six identical ways. So because of symmetry, the current through this edge BE would be I by 6. Okay, so that is the correct answer. Okay, right. So next, there is another interesting situation given to you. So you've been told the volt ammeter characteristics of an unknown device connected in a circuit in series with a resistance and a battery is shown in figure. If the value of the resistance R is 300 kilo ohms, then and the terminal voltage of the battery is V0, which is 5 kilovolt, you would find the potential drop across the device. So why don't you guys try this? Again, let's see. The device that behaves very differently, right? So what can you see from the graph? Think about that and try and answer this. Okay. Okay, guys, come on. Think about this and try and give me an answer. So again, I'm going to wait for 1 more minute for you guys to try. And if nobody has an answer in the next 1 minute, then I'll go ahead and solve this. Hello AP, how are you? So see this problem and try and answer. Okay, so AP thinks it's B. Okay. Okay, let's see if AP is right. So what you realize is that the maximum current that can pass through this device is 10 milliampere. Okay, all right. Let's imagine, and that would have happened if the potential difference across it was more than 1 kilovolt. Okay, the maximum current through the device was 10 milliamperes for delta V greater than equal to 1 kilovolt. Okay. So obviously, because of that, our entire circuit cannot have a current of more than 10 milliamperes. Okay, that is what you have to figure out. As a result, the circuit cannot have a current greater than 10 milliamperes. Okay, now assuming it is 10 milliamperes, assuming I equals 10 milliamperes, so delta V across R, what is the potential drop across R going to be? So delta V across R is, so R is 300 kilo ohm. So 300 into 10 to the power minus 3 into 10 to the power minus 3 plus 3 into 10 to the power minus 3. Okay, so this and this would have gotten cancelled. What I get is 3 kilovolt. Okay, so if 3 kilovolt is the potential difference, if the current is 10 milliamperes, corresponding, what is the corresponding corresponding delta V across the device. Now you realize that would be 5 minus 3 kilovolt equals 2 kilovolts. So yes, if I assumed that the current is 10 amperes, then that satisfies this value. Okay. So turns out the device has a potential difference of 2 kilovolts, and yes, it will allow 10 milliamperes of current to pass through it. If the potential drop came out to be less than 1 kilovolt, then I would have had to reassess my calculations. Okay. Then I would have had to imagine a value of current, another value of current. But since the value that uh, I imagine the current to be 10 milliamperes and the corresponding potential difference is coming out to be greater than 1 kilovolt. So my assumption is correct and B will be the correct answer. So well done, AP. You were absolutely right. All right. So Advocate Isam Prajapati also says B. So great, great, great. Both you guys are absolutely correct. All right. So here is another question. Now, this can be very, very tricky. Okay. So this question tells you that a network shown in the figure consists of a battery and five unknown resistors. Okay. And you've been told when an ideal ammeter is connected between the terminals A and B, its reading is a 4 amperes. And when a resistance of a 3 ohm is connected in series with the ammeter, its reading becomes 2 amperes. Now you've been told the ammeter and the resistance are disconnected and an ideal voltmeter is connected between the terminals A and B. So what would the voltmeter read? Okay, so this again, now this is a question that is an Olympiad level question actually. Okay, because you guys can try, but the method that you will want to use to solve this is something which is not strictly in JEE syllabus. So you have a lot of circuit analysis techniques which you will learn in your graduation. Okay, in your college that is. So there are methods which okay, I'll name it. So there is one method called Thevenin's equivalence, and then there is one method called Norton's method. So those methods you will generally study in your graduation. So this problem will only be solved using that. Okay. Otherwise it can get very, very, very lengthy and tricky. Okay. So you can still give it a shot, and let's see if you can figure something out. Okay. Hi, family home. How are you? Yes, I know, I know. I remember this ID also, Abhijit. So how are you doing? So would you want to give this question a try? Now, you will generally not see such questions asked in JEE. You will have a couple of you would have seen a couple of methods, a couple of problems solved using this method in Krotov. But J doesn't usually ask you questions which cannot be solved using symmetry and KVL KCL. Okay, they will like to stick to that. So again, as I said, this is something that you usually learn in your graduation. So good sir, I've tried and was not able to solve. All right, yes, all right. That is pretty fine. That is absolutely fine. So okay, so Thevenin's equivalence. Let me tell you. So Thevenin's equivalence suggests that any circuit, any combination of resistors and batteries in a DC circuit can be replaced by a single battery and a single resistor between 2 points. Again, you can Google and find out the proof of this. Oh, I am good here. I am absolutely fine. I hadn't been too well of late because of the change in weather. I think I caught some bit of cold, but now I'm much better. Thank you for asking. Okay. So what essentially what you will do is, so in this method, so you have points A and B. So the entire circuit between these 2 points A and B, this entire thing can be replaced by a single battery and a single resistance. So equivalent, therefore, equivalent of the circuit shown can be drawn as follows. So you can imagine that between points A, you have one resistance and you have one battery. Okay, so points A and B, you have a single V of V equivalent and single R of R equivalent. This is the entire circuit. The entire circuit can be replaced by this. Okay, so Gopi Krishna says 6 volt. No, 6 volt is not the answer, Gopi. Okay, I think if I remember correctly, the correct answer was 12 volts. Okay, this is the correct answer. Okay. So now what have you been told? You have been told that when an ideal emitter is connected between terminals A and B, the reading is 4. So now instead, I will forget about this circuit and I will think of this as this equivalence. This is the equivalent thing that I will imagine. Okay, now what I would like to do is, so for the first situation, for the first case, I will imagine that this is my terminal A having a resistance R equivalent and having a battery V equivalent and having an ammeter A. So I have V equivalent and I have R equivalent and I have an ideal ammeter. And the ideal ammeter reading has been told to me as, I think 4 amperes, right? 4 amperes. So therefore I can say V equivalent equals 4 times R equivalent. That is going to be my equation number 1. Now similarly, सर ऐसे सेल और रजिस्टर कब डालना है कैसे पता चलेगा अगर ऐसे कोई दो रैंडम पॉइंट्स के बीच में कुछ कुछ चीजें बताई हैं तो फिर करना है usually you won't use this usually in J especially you won't use this if you have something like this in which things are being done between 2 points only and information between 2 points only is given then only you replace the entire circuit between those 2 points by a single equivalent battery and a single equivalent resistance ठीक है वो देखोगे जब क्वेश्चंस तो समझ में आ जाएगा कहाँ कहाँ लग सकता है कहाँ कहाँ नहीं लग सकता ओके नाउ सिमिलरली फॉर द सेकंड केस also for the second case in the second case what has been told to you again इसका पूरा proof भी है there is an entire proof of this but it should be obvious in any case थोड़ा सा intuitively भी दिख रहा होगा you can google the proof also okay so there is a long proof but you can find that fine okay Gopal Gopi Krishna now next you were told that when a resistance of 3 ohm is connected in series with the ammeter the reading becomes 2 so for the second case what I know is how much was the resistance 3 ampere and 3 ohm and the reading becomes 2 for the second case what you have is again you have A and you have B you have V equivalent R equivalent and now what you're doing is in the external circuit you now have a resistance and an ammeter okay so now you realize the reading is 2 so for the second case what you realize is that this is 3 ohm so you realize that V equivalent would be equal to 2 times 3 plus R equivalent. This is your equation number 2. So you have equation 1 there and equation 2 here. So now you will solve equations 1 and 2. Now from equations 1 and 2, what you will realize is that 2 times 3 plus R equivalent equals 4 times R equivalent, correct? So that will give R equivalent as 3. Okay. And since R equivalent is 3, what is V equivalent? V equivalent becomes 12 volts. Okay. I hope you guys followed me this far. Now for the third case. Okay. Add the page. Again, as I said, this is not something that is in your JEE syllabus. So that is why it is very unlikely that IIT JEE would ask you such a question. Okay. Now for third case. Third case, what have you been told? You have been told that between points A and B, the ammeter and the resistor are disconnected and you applied an ideal voltmeter, correct? Now, if you apply an ideal voltmeter, then ideal voltmeter is supposed to have infinite resistance. So what will that read? That will simply read the potential difference of the battery. Okay, got it? Yes, that was what was given. An ideal voltmeter. Please note that the voltmeter is ideal. So since the voltmeter is ideal, you will realize there will be no current in the circuit. Okay, you will realize I would be 0. Therefore, the reading that we will get, therefore, reading of voltmeter will simply be equal to 12 volts. Okay, got it? If you apply your KVL, you will realize that a voltmeter reading would be simply the potential difference between points A and B, which will simply be 12 volts. Okay, so that is how you would have gone about solving this. Again, you can't solve this unless you know this method. So that is why I said this is a problem that is more likely to be asked in Olympiads than in advance. Because advance usually doesn't like asking problems from such methods for which you have to use special methods. Okay. Again, they can ask you these things in paragraph form, so they have a habit of doing that. Mind that. So that is why the correct answer is 12 volt, and that is how to solve it. I hope you guys followed this. Now, if you see a question like this, then you know how to go about this. Okay, is the approach clear? Again, you can read up on Thevenin's equivalence also. Okay, you can read up on this, but then again, this is a special method used only in very few questions. So if you are only focused on IIT exam, then you might even skip it. Okay, if you are preparing for your Olympiads and want to study some more, then you can look up this Thevenin's method and also Norton's equivalent. It is a very similar method. Norton's method is also very similar. Thevenin's equivalence and Norton's method, both are very similar approaches. They talk about replacing an entire circuit with a single. This tells you about a voltage source, and that tells you about a current source. Okay, all right. So if that is clear, should we move ahead? Here is another interesting question. Okay. So here you've been told a network shown consists of an ideal battery. Yes, you will find this in your graduation books. Okay. You will find these methods in your graduation books of circuit analysis. Okay. Graduation level books में मिल जाएगा अभिजीत. ठीक है. बाकी नॉर्मल तुम्हारी 11 12 लेवल की बुक्स पे नहीं मिलेगा. ठीक है. ये ग्रेजुएशन लेवल बुक्स पे ही मिलेगा तुमको. उधर बुक्स में मिल जाएगा तुमको. You can Google it also. Google पे मिल जाएगा तुमको. It's not that big a deal. जो इलेक्ट्रिकल इंजीनियरिंग करेंगे, इलेक्ट्रॉनिक्स एंड इलेक्ट्रिकल इंजीनियरिंग, they will study all these methods. Thevenin's equivalence, Norton's method, and there are so many other methods also. Right. So again, those star delta conversions, again, those are the kind of things which usually IIT JEE never asks. So again, if your focus is only on IIT JEE, then you can skip all these methods. Okay. नहीं सर उधर नहीं ओके सर मैं गूगल करता हूँ सेशन के बाद हाँ वो कर लेना so again as I said IIT JEE does not usually ask you too many questions on these special kind of methods. So if you are only focused on your IIT JEE exam, then no need to worry about this too much. Okay. All right. So here, let's try another one. So this question says a circuit shown consists of an ideal battery, an ideal voltmeter, and an ideal ammeter. So every circuit element is ideal. Okay. Now several resistors with different values and a rheostat are connected. Okay. If the resistance of the rheostat is increased by a finite amount, how will the readings of the voltmeter and ammeter change? So this is a very simple question. This you should be able to answer very easily with logic. Okay. So option A says both will increase. Option B says voltmeter reading will decrease and the ammeter reading will increase. Option C says voltmeter reading will increase and the ammeter reading will decrease. Option D says voltmeter reading will not change but ammeter reading will decrease. What do you think is the correct answer? Think about this. This should be easy to answer. Okay. Yeah, I hope all the options are visible to you guys. Just in case they are not, so let me just do it like this. Now I guess all the options should be clearly visible. Okay. Okay. So Gopi Krishna says C. Okay. Okay. All right. How about others? Anybody else having any thoughts about the answer? It seems quite approachable. Give a minute to think. हाँ, this is quite approachable. This is quite approachable. अगर थोड़ा सा सोच लोगे हो जाएगा. थोड़ा सा सोचना है बस. थोड़ा सा लॉजिकली सोचना है बाकी कुछ भी नहीं है. Okay, AP also says C. Oh, okay. Okay, so hint is try to break this circuit into two parts. Huh? Try to think of these two parts separately. So this part of the resistance circuit, take this separate and take this part of the resistance circuit separate. Think of these two parts separately. Yes, C is in fact the correct answer. So very well done. All you guys got this correct, which is very impressive. So obviously, the moment you increase any resistance in any combination, the net resistance will increase. That is pretty obvious, right? Okay, so that should be very obvious. By increasing the rheostat resistance, the net resistance of the circuit will obviously increase. So if the net resistance is increasing, therefore the current decreases. Okay, so again that also would be very clearly seen. Okay. Which is the best book, Erudov or Krutov? I think for JEE, I think Erudov is much better. In Krutov, a lot of problems are not relevant to the JEE syllabus. Okay, they tend to go beyond the JEE syllabus. They use again as I said, they mostly are more relevant for Olympiads. Krutov is more relevant for Olympiads, and Erudov would be more relevant for IIT JEE. Though even in Erudov, there are some problems which are out of JEE syllabus, but I think more problems in Erudov. I think almost 80 to 90 problems of Erudov are pretty relevant, while it's the other way around. In Krutov, only probably 40 to 50% problems would be relevant to JEE. Okay, so that is why I think I always advise Erudov. So you realize, so the current reduces. So obviously the value of I would definitely decrease, correct? Now, if the current in the net current in the circuit decreases, then what you will notice is that if this thing can be treated as one single resistance of R equivalent, then the potential drop across this entire section will also decrease, and hence the potential difference across the section 2 will increase. Okay, so let's call this section 1 and that section 2, and I can say since I decreases, therefore delta V across 1 also decreases, because for that part the resistance remains the same and the current has decreased. Okay, so also decreases, and since you know the total, and since the delta V1 plus delta V2, ये तो constant है, this is constant equal to the V of the battery, therefore delta V2 increases. Okay, thus option C is correct. In any case, I think most of you were able to figure this out in any case. Okay, so shouldn't be much of a problem. So अभिजीत से सर पाथफाइंडर के सॉल्यूशंस ऑनलाइन मिलते हैं मिलते नहीं, और मैं फिजिकल कोचिंग नहीं करता, बट सर मैं पाथफाइंडर सॉल्व करना चाहता हूँ, मैं सिर्फ एमसीक्यू में प्लस ज्वाइन किया है, सिर्फ एमसीक्यू मैंने प्लस ज्वाइन किया है, क्या करूँ मतलब, अगेन अगेन डाउट क्लियरिंग सेशंस में आ जाया करो, सारे टीचर्स के डाउट क्लियरिंग सेशंस होते हैं प्लस पे, राइट? सो देख लो यार, कुछ कुछ टीचर्स बाकी के डाउट्स भी ले लेते हैं आपके, ठीक है? सो गेट इन टच विद द टीचर हु इज रेडी टू टेक योर डाउट्स, ठीक है? और खुद से ट्राई करो, और जो प्रॉब्लम्स नहीं बनेंगी तो वो पूछ लो टीचर से, ठीक है? दैट इज इट, और तो क्या ही हो सकता है. All right, let's move on to the next one. Now, this is a very interesting one again. The circuit shown in the diagram extends to the right to infinity. Okay, okay. So let's try and fit this in. Yes, this is much better. Okay. So you've been told that the circuit shown in the diagram extends to the right to infinity. Each branch resistance is denoted by small r. What is the resistance between the terminals A and B? Okay, so try this one. This should be interesting. Again, this is also not too difficult. A very standard kind of a variation of your infinite ladders. So let's see if you try, you should be able to figure this out. Okay, I'm sure you guys, whoever is trying Pathfinder, would have solved the standard infinite ladder problems, right? So Gopi Krishna says the all right. So I'm sure Gopi Krishna has already solved these problems, right? Because otherwise you can't be giving such quick answers also. All right. एडो में भी टाइप के क्वेश्चन हैं, हाँ एकदम है, एकदम है. आई टोल्ड यू ना, एडोफ इज अ वंडरफुल बुक. एडोफ इज अ मस्ट. That is what I personally believe for a top rank in JEE. If you're aiming for a top rank in JEE, especially in the top 2000 at least, then you should be solving Erudov. Pathfinder maybe not, but Erudov definitely. Yeah, that will give you a good practice. That will allow you to widen your thought process, and the see even if JEE doesn't ask you all tough questions, but the moment you start trying tough questions, your thought process becomes better. It becomes stronger. Your fundamentals become stronger when you're thinking about analyzing tougher situations. Hello, Siddharth. Siddharth says, sir, what will be the minimum cutoff for KVPY essay? Please reply. We have exam tomorrow. Okay, so again, it's very difficult to predict the cutoff before the exam, no? Plus, this year I wouldn't like to comment on that, because one, this year I have been sitting at home taking online lectures only, so I don't have much idea about how the KVPY exam cutoff is going to be. So I'll only be able to uh, tell you about the cutoff once I've seen the paper and once I've spoken to a few students. Okay. Yes, Pathfinder is much harder than Erudov. Yes, Gopal Krishna, Gopi Krishna, you are absolutely right, and that is why I said that if you are aiming for a top 2000 rank, then Erudov I think is a must, but Pathfinder you can still leave out. Pathfinder you should only try once you have done the entire Erudov also, and once you still have a lot of time in your hands, and once you think that okay, now I'm very sure I'm getting a top 2000 rank, and now I want to aim for maybe top 200 rank or something. Okay. Minimum, sir, if the paper is very hard though. Okay, so minimum is usually mm, around 33%. It usually doesn't go below that. 35%, 40%. Those are the usual cutoffs. Okay. Anything above that should be fine. Usually those are the safe scores. Okay. Okay. Let's see. Again, as I said, I will be able to comment much better once I've seen the paper and once I've spoken to students, gotten their inputs. So usually, when up to last year, when I was in offline setups, it was easy. Okay, so we would constantly interact with our students, get to see the paper, also talk to them. So it would be easier for us to predict cutoffs. But now, for 1 year, I have been stuck at my home. Taking classes online only, so it might be a little difficult for me to hit the cutoff right away. Tomorrow, I am also writing KVPY. Wish me, sir, please. Absolutely, yeah. All the best to all the students, and I hope you guys do absolutely fabulous in that. And Gopi Krishna, from the kind of answers that you've been giving here, so you have had a lot of practice. It seems. I'm sure you will do well in the KVPY. Okay. All right. So again, so I think all of you guys have given the correct answer for this. So yes, the correct answer is in fact C. Again, the question is fairly straightforward and simple to solve. All these questions, all these resistances are each right, and you see that there is a symmetry in the circuit about this line. Okay, so you realize if you can find the equivalent resistance between here and here, then the equivalent resistance between here and here would be simply double of that. Okay, sure, yeah, Arnav, all the best, crack the KVPY, why not? So all you need to do is now focus on only the first half of the circuit. If I can find the R equivalent of this, so the R of the net R from A to B would be double of that. Okay. So that is the trick that we can use. So let's draw this point A. Then you have R. Then you have this series starting, right? Till infinity. Sir, I done by removing the conducting wire as current does not pass through it. Yes, absolutely. You could have done it by that also. Absolutely, because all these guys would be at the same potential. So Gopi Krishna is absolutely right. You can simply remove this also. You can simply remove this also. You can what you can say is that so if I assume that the potential here is V, the potential here is zero, then the potential at all these points you realize would be V by two. V by two because of symmetry. Correct. So no current would flow through this wire. So you could have simply removed this wire also. So absolutely, that is also one way of doing this. I am just doing it by another way. You could have also said that yes, I could have treated this as one circuit, and or basically what I am doing is I am adding another wire. So just like you removed this wire, I am adding another wire. So I am creating a symmetrical circuit like this. Then all I'm bothered is calculating the equivalent resistance of the upper half, and the net would be double of that, right? So that is, I mean, both approaches are absolutely fine, right? No issues with either. Now, what you will realize is again, if I do this, so this is my point A. Let's call this point C, and let's call this point D. Okay. Now, what you will realize is that between points C and D, if the R equivalent is R1, okay, let the R equivalent between C and D equals R1. So I can redraw this and say that I could have had this circuit R, this, and here again, between these 2 points also, the equivalent resistance would have been R only. Okay, between D and F, E and F. Okay, from symmetry, from infinite symmetry, R equivalent between E and F is also equal to R1. So that is a standard approach of solving these infinite ladder problems. Okay, R1, R, and R. So what I can now say is, so the equivalent resistance between C and D, what will that be? So I can say therefore R plus R1 over R plus R1, which is the equivalent resistance between C and D, should be equal to R1 itself. Okay. Now from here you will find R1. So you will have a quadratic R square plus RR1 plus RR1 equals RR1 plus R1 square. So this gets cancelled. You have as R1 square minus RR1 minus R square equals 0. So solve this quadratic. R1 would be minus B. So plus R plus minus R square plus 4R over 2. Okay, so thinking I'm getting the wrong. My bad, my bad. I wrote the equation wrong. The equivalent resistance between C and D are equivalent. C and D, that would have been R into R plus R1 over R plus R1. And that would have been R. So from here I would have gotten R square plus R1R equals 2RR1 plus R1 square. The quadratic I should have gotten was R1 square plus RR1 minus R square equals 0. So from here I would have gotten R1 as minus R plus minus root 5R square over 2. Okay. Okay. So Gopi Krishna says, sir, what do you think or guess about tomorrow? PY physics paper. So what is there to think or guess? Just see each problem. You have practiced enough, so take every problem and solve it. Yeah? I'm sure you will know how to solve every problem. Just be confident. Just be confident, and that's about it. That's about it. Nothing to worry about. Nothing to think about too much. So since R1 cannot be negative, so R1 is positive. So I will realize R1 would be equal to minus R plus R root 5 over 2. Okay, so this is the equivalent resistance between C and D. Okay, this is the equivalent resistance between C and D. So the equivalent resistance between A and D, what will that be? Therefore, R equivalent between A and D is equal to R plus R1, right? So that will be R taken common, root 5 plus 1 over 2. And hence, let's call this R2. R equivalent between A and B, I know that would be double of this. R A B equals times R2, which is equal to R5 plus 1. Okay, so yes, that is the correct answer. I've solved it off. Shall I go for Leslie Alex? I really wanna try that book. Is that worth? Again, that is something which you can try for fun. Again, not going to be very helpful for your ITJ. Yeah, I know. Krutov would be more relevant. So Gopi Krishna is right. Absolutely correct. So again, you can try Leslie Alex, but before that, yeah, I would also advise. Before that, you should try Pathfinder and Krutov kind of books. Okay. Again, you should only try those if you are aiming for Olympiads. And there is another book that has a good collection of problems, Physics Galaxy, which is by Ashish Arora sir. You can try that also. That also has a pretty decent collection of problems. Okay, so if you are aiming for top ranks or your Olympiads, you can go for that also. Okay. All right. So here is another question for you. Okay, let's see if you guys can figure this one out. Okay. So this says an ideal battery of EMF E is connected in series with an ammeter and a voltmeter of unknown internal resistances. Okay. Yes, Physics Galaxy it is called, though it comes in a lot of volumes. It comes in 4 volumes. So yes. So that is what, no, that is more relevant for your Olympiads. Again, IIT JEE would be more straightforward. That all right. You don't see very creative problems in IIT JEE. They are the IIT JEE problems are more relevant, more straightforward. Okay. No, sir, I wasn't able to solve this. I tried it earlier. Okay. Okay. No problem. No problem. So keep giving it a try. Keep trying different books, and think where are you going wrong. You will figure it out. I'm sure. किसी कोई दिक्कत है नहीं. Okay. So how about this problem? This says an idle battery of EMFE is connected in series with an ammeter and voltmeter of unknown internal resistances. Now, if a certain resistance is connected in parallel with the voltmeter and the ammeter readings become 1 by neta and neta times their respective initial values. And what was the initial reading of the voltmeter? Okay. Okay, so Gopi Krishna says C. All right. Let's see. Okay. How about others? I think so. You will find the PDF online. I think you should be able to find the PDF online. Okay, so don't worry about it. I think if you're solving these many problems in physics, I think for JEE your physics should be pretty sorted, yeah. इतना भी tension मत लो. In fact, you should be pretty good with your Olympiads and your KVPY exams as well. Okay. So how about this problem? So anybody else trying? Because Gopi Krishna says C. Gopi Krishna says it's C. Okay, so let's try and logically can I answer this? So if I connect a resistance across the voltmeter, so the net resistance of the circuit would go down. Okay, so obviously the ammeter reading absolutely becomes increases and the voltmeter reading decreases. Okay. Hmm. Okay. No. There is yeah, but one thing I can say for sure, Gopi, logically one thing I can say for sure, it cannot be C. It cannot be C. This is definitely wrong. That's what I was thinking. There's something wrong about this option. what you realize is this value is greater than the EMF. But it can never be C. You realize the option C, it is greater than the EMF. The voltmeter reading ever would have been greater than the EMF. Think about this. How could the voltmeter reading be would have been greater than the EMF of the battery? Yes, B is in fact the correct answer. B is the correct answer. So whenever even by if you made some mistake, in your calculations, just check your answer logically. Okay, that is what I felt weird about this option. I thought there is something wrong with this option. This definitionally cannot be the answer. B is the correct answer. Yes, and I remember it now. So okay. So what you realize is that let's imagine. Yes, let's draw a circuit where you have a voltmeter and you have an ammeter and you have this idle battery. Okay, and finally, you have voltmeter. Along with it, you have a resistance and you have an ammeter. So this is the second situation, correct? Okay, so yes, I figured. But again, always check your answer logically, at least. That'll sometimes save you from marking the wrong answer. Okay. So let's imagine for the sake of simplicity that here the resistance is R2 and the resistance of this is R1 and the resistance that you connected in parallel is capital R. Okay, let's imagine that. So if you connect this R in parallel, then the ammeter reading becomes eta times. So if the ammeter reading becomes eta times, so what can I say from the given data? Can I say from the given data R equivalent would be neta times R1 plus R2 1 by neta times this. So the equivalent resistance must be dropping by a factor of neta. That is why the current is going up by a factor of neta, correct? So I can definitely say that once. That is the first thing that I can say. Now the second thing that I can say is now since the current has become neta times, okay. So let's see what is the drop across this. So the drop across voltmeter delta V across voltmeter would have been EMF minus R1 neta times I naught. Okay. Yes, and that would have been I naught being the initial current. That would have been L naught minus R1 I naught and by neta. So this was the initial drop and that is the final drop. Okay, do you guys agree? That is according to the data. Okay, so from here, what I can say is, okay, so let's see. Definitely, I naught would have been over R1, R2, right? That would have been the initial current. So if I replace that value also, let's see what I'm getting. I'm getting neta minus R1 neta epsilon over R1 plus R2 equals epsilon 1 by neta times epsilon minus R1 epsilon over R1 plus R2. Okay, so I can get rid of all the epsilons. Okay, and hence find a relation between R1 and R2. Okay, from here, let's find a relation between R1 and R2. Let's see what we are getting. From here, I will get eta times 1 minus over equals 1 minus plus R2. Correct. Okay. So again, now I will solve this, find a relation between R1 and R2. So let's see what I get. Eta minus 1 equal to get R1 over R1 plus R2. And here again I have neta minus plus square minus 1. Correct. Just look at this. Okay. Now I can again write this as neta minus 1 equals R1 over R1 plus R2. This I can write as neta minus 1, neta plus 1. This and this gets cancelled. What I'm getting is R1 plus R2 equals R1 plus R1. What I get is R2 equals neta R1. That is the relation that I got. Correct. Now the initial reading would have been delta V initial for the voltmeter. That would have been R2 I naught. Okay. R2 I naught would have been R2 into I naught would have been EMF over R1 plus R2. Right. Now instead of R2, I will replace theta R1. So all the R1s will get cancelled, and what I get is this. Okay, which I think was option B. Neta epsilon in over 1 plus neta. Okay, so this is one way of solving it. I'm sure you can solve it using other ways. So this is the correct answer. Okay. So I did not try to bother about the R that we are adding much. Okay, I only assumed R1 and R2 to be the resistances, and from the given data, I found a relation between the two resistances. Okay, and that finally gives us the answer as this. Okay, delta V initial is this. We take the voltmeter to be as eta and ammeter as 1 by eta, then you will get option 1. Okay. Okay. Sure, I'm sure. Then you would have gotten the reverse of this, right? If you get the reverse of this, then R1 it becomes neta times R2, right? If you reverse those things, then I'm sure you will get a reverse relation here between the resistances. And what you are saying, I think in that case, R1 would have been equal to neta R2. And if that is the thing, then you would have had R2 over 1 plus R2 plus neta R2. So yes, 1 plus. Yes, you are absolutely right. Then I would have had option A. Correct. Absolutely correct. Right. I can see that from here also. If the basically replace neta by 1 by neta, no? All you need to do is replace neta by 1 by neta, and that's it. Correct? All right. So here is the next question that I want you guys to try. So this says in the circuit shown, all capacitors are idle. Initially, the switch is open, and only one capacitor, and the only capacitor A was charged. So this is your capacitor A. Only this capacitor was initially charged. Now you've been told after the switch is closed, you notice and steady state established, then the charge on the capacitor A becomes 5 micro coulombs. What was the initial charge on this capacitor? Try this. Okay, so let's see how many of you can figure this out. Again, this is a pretty standard problem that can be easily asked in your JEE. This is a good JEE level problem. This is the kind of questions that JEE likes to ask. Simple, straightforward methods of analysis, just a little bit of thinking, and that's about it. Let's see how many can get this right. Right. Again, so I'll wait for probably 2 to 3 minutes for you to figure this one out. Okay, see how many answer. I think the audience for this kind of session is has reduced. I think it's more to do with the upcoming mains. People are probably more focused on mains right now. That is why I'm not getting too many people coming for such sessions. I think probably after the mains is over, I would get more crowd. Let's see, let's see. So how many of you are trying this problem then? So Gopi Krishna is taking surprisingly long to answer this one. He has an answer within 1 minute. So far, he has given me answers within 1 minute. This is the first time in 2 minutes, and there is no answer from Gopi. Huh? What happened, Gopi? It's not that difficult also. Yes, unless Gopi got disconnected. Possibility. All right. I hope you guys are trying. So I'll wait for a while longer, maybe. Since people seem to be taking more time, this one, I don't know. I don't know. This is not that difficult, also. Okay, so AP says B, right? We'll have to see that. Okay. All right. So since there is again too many people trying this, so all right. So let's go about this thing. So AP says B, and let's see if B is correct. In fact, so first of all, when I want to when I close the switch, so let's just mark some potentials at different points, and let's try to draw a simplified version of this circuit. Okay, so this is capacitor A. So let's call this point. Let's start naming some points. Let's call this point 1. So this also becomes 1. Obviously, this is, imagine, 2. This also becomes 2. This is 2. This is 2. Imagine if this is 3. So this being 4. So this is what the equivalent circuit looks like. What you realize is that the potential difference across this capacitor is 0. So you can simply get rid of this. Okay. And once you draw the equivalent simplified version of the circuit, let's see how it looks like. So from 1, you have two circuits. So from starting from 1, you have two capacitors. Then first one goes into 3. Uh, Here again, I have two capacitors. So 3 goes to 4, 4 goes to 2. Here I have one which goes to 2. Okay, so this is 1, this is 1, this is 3, this is 4, and this is 2. And this is also 2. So this is what my equivalent circuit looks like, correct? Correct. So this was my capacitor A. Now, these were all identical capacitors. If all were identical, let's imagine that their capacitance was C. Let the capacitance of each capacitor be C. Let capacitance of each capacitor C. So I want to find the equivalent of all this. The final equivalent capacitor that I've connected in parallel to capacitor A. Okay. So for all this, you have these two in series. So this is C and C in series, that will make C by 2, and C by 2 and C in parallel. So that would make, what I will have is, I will have A, and then with A I will have one capacitor here and one capacitor here, like this. So this is C and this is 3C by 2. Correct. Sir, I have a small doubt in question 1 in this lecture. Okay, tell me. Tell me. So again, these are again in a series. So the equivalent of these two, the equivalent of these two, be some C equivalent or C dash. Let's call it C dash. So I know C dash would be equal to 3 by 2 over 5 by 2 C. That is 3 by 5 C. Okay. So essentially, you had a capacitor C and you connected with it in parallel. C was connected in parallel with 3C by 5. Okay. So finally, if the charges are Q1 and Q2, okay, then what I know is that, okay, okay, we will come to that. Let's see. Potential drop is 3V, okay, 3 volt. Okay, let's see, we'll see. Okay, so first I know these are the two capacitors connected in parallel. So can I say Q1 over C should be equal to Q2 over 3C by 5. So I know Q2 would be 3 by 5 Q1, and Q1 has been told to me as 5. So therefore, Q2 becomes 3 microcoulomb, and Q initial would have been Q1 plus Q2. All the charge was residing on capacitor A. So the answer would be 8 microcoulombs. Okay. So B is your correct answer. Okay. Okay. Yes. So potential drop would be 3 kilovolt. Okay. Why? Why would you? So what is the maximum current that can go through a circuit? Think about this. Think about this. Let me check the answer also, just in case. No, we have the right answer. We have the right answer, Gopi. Okay, so see, what have you been asked? Find the potential drop across the device. Potential drop across the device, not the resistance R. Now you have a total of terminal voltage 5 kilovolt available for you. Okay, so there are two possibilities. There are two possibilities. Either the potential drop across this is less than 1 kilovolt or it is greater than 2 kilovolt. Correct? In any case, the maximum amount of current that is allowed in the circuit would be equal to 10 milliamperes. Correct? So assuming that 10 milliamperes is flowing, so what said is that the graph tells me that the maximum current allowed through the device is 10 milliamperes. Okay, so since it is in series, okay, since it is in series with the resistance, so the maximum current that can flow for across this R is also 10 milliamperes. Correct? Okay, okay. So the circuit diagram is something like this. You have a device T and you have R, and then you have this battery. For this battery, your terminal voltage has been given. I don't need to consider the internal resistance. For the given situation, I know my terminal voltage, so I can treat this as an idle battery now of 5 volts, right? 5 kilovolts. Okay. So now what I'm saying is because these two things are in series, so what I said is that the maximum current through the device is 10 milliamperes for delta V greater than 1 kilovolt, correct? So as a result, the circuit itself cannot have a current greater than 10 amperes. Now, assuming that current in the circuit was 10 milliamperes, what would have been the potential drop across the resistance R? Across the resistance R, the potential drop would have been 3 kilovolts. Okay. So if the potential drop across the resistance R is 3 kilovolts, then the potential drop across the device would be 2 kilovolts, right? And 2 kilovolt does satisfy this condition also. Yes, it would have had a 2 kilovolt potential drop and a corresponding current of 10 milliamperes. Okay. All right, great. 2 kilovolt is the correct answer. Don't worry about it. All right. Okay, so yes, so for this, the correct answer is 8. Again, I think AP had said B for this, right? So AP, well done. You were absolutely right. Okay. Again, I hope everybody followed the solution. This solution is pretty standard, pretty straightforward question. Again, a very advanced level question rather. Okay, pretty simple advanced level problem requiring you to know to simplify the electrical circuit and know how capacitors connected in parallel are related. Okay. All right. So this is the final question of the day. This is the final question of the day. This is the last question, and then we will be wrapping up today's session. This question tells you the figure shows a part of a large circuit in which the potentials of some points are known. Each capacitor has a capacitance of 5 microfarads, okay, which of the following statements is true. Okay. So you've been asked, from the given information, the potential of point O can be determined, but that of B cannot be determined. Option B says, from the information given, the potential of both O and B cannot be determined. C says, if the charge on capacitor C2 were also specified, then the potential of O can be determined, but that of B cannot be determined. And D says, if the charge on capacitor C2 were also specified, then the potentials of both O and B can be determined. Okay, so which options do you think are correct? Take a look at the circuit here. Think about this. With the given data, what all can you calculate or what all can't you calculate? Can you calculate the potentials at points O and B? That is the first question. With the given data, can you figure out the potentials at O and at B? So Gopi Krishna says, I think option B. Okay. Okay, let me give you a hint. More than one option is correct. More than one option is correct. Okay. So think again. Think some more. Okay. Okay. So let's see what all do we know about this circuit. What all do we know? I know the potential here. I also know the potential here, right? Because this has been earth, so the potential here is 0 volt, and the potential here is known 10 volt. Now each capacitance is known. Capacitance is known. Hmm. Okay, so how can A and B both be correct, Gopi? From the given information, you say the potential of point O can be determined, but that of B cannot be determined. And you earlier said option B, which said potential of both O and B cannot be determined. Okay. So A and B simultaneously cannot be correct. Gopi, what are you saying? They are contradicting each other. No. A and B aren't they contradicting each other? Think about this. Yes. 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 B and D both are correct. Absolutely. So for this, you don't even need to write any equation, not need to solve anything. What you know is here again, if I do not know the potential of this, so V of O is not known, then the problem is that I don't know the charges on any of the capacitors also. Okay. So with the given amount of information, okay, okay, and this is also not known. Okay, this is also not known. Now, if you knew the charge on a few capacitors, then maybe you could have done something. Now the problem is I don't know what are the charges on each. Okay, I only know the capacitances. I only know the potentials of these points. So if I knew the charge on one capacitor also, then I would have been able to figure out what the potential change would have been across a capacitor, and hence I would have figured out the problem figured out the potential of O, right? Similarly, since I don't know the potential of O and I don't know the potential or the charge on capacitor C2, so I cannot determine the potential at B also. Okay, okay, never mind, never mind. So definitely B is definitely correct. From the given data, from the given information, the potentials of both points B and O cannot be determined. So, okay, this is absolutely correct. Now, if charge on capacitor C2 was known, then what can I do about that? So let's see what kind of equations I would have formed. Okay, so if I assume the potential here is, if I assume the potential here is V and the potential here is V dash. So I would have gotten these different equations. I would have imagined the charge here minus Q1 plus Q1. I would have imagined again a minus Q4 plus Q4. I would have imagined here, let's say plus Q2 minus Q2. Okay, now if this charge was known, and I don't know the current through this, right? Current through. Again, are we talking about steady state? Okay, okay. Now, once the charge was known, I would have been able to tell you V minus V dash. That is obviously known to you. That would have been Q2 over C2. Okay. Now, what else? What else could have I found out? I would have said that V plus 10 would have been equal to Q1 over C. I would have also said V equals Q2 over C. Okay. And if I could have, I don't know, say the potential here would have been V double dash. And the third thing I could have said was the sum of all these charges would have been zero. Okay, so one equation I would have gotten there. I could have said Q1 plus Q2 plus Q3 plus Q4 would be zero. Okay, so let's imagine you have a steady state. Let's imagine you have a steady state. So if you have a steady state again, because that's the only option in which I could have figured something out. So in steady state, this would have been 10 again. Would have been 10 volt, and then I could have written also V minus 10 would have been equal to P over C. Okay. So here what I realize is I have how many unknowns? I have 1, 2, 3, 4, 5 unknowns and 4 equations from this I would have gotten, and one thing Q2 would have been given to me. Okay. So then yes, I could have solved for all. Okay, assuming that only steady state solution has been asked. Yes. Assuming steady state solution has been asked, I would have formed equations for potential differences. So I would have gotten 4 equations, and then I would have had charges. One equation for all the conservation of charge, that the net charge on all the capacitors would be 0. Okay, and that would have helped me solve all the equations and get all the answers. Okay. So here, as I said, I have, if I wrote all the equations here, 4 equations like this and 1 equation due to conservation of charge. Q1 plus Q2 plus Q3 plus Q4 equals 0. Okay. Again, would have been Q. Right. So I would have had 6 unknowns or 5 unknowns because Q2 was known. So if Q2 was known, then I would have solved for all. We have done great discussion today. Thank you, sir, so much. But the last question was disturbed me a little bit. Don't worry about it. Don't worry about it. These are very simple questions, okay? That's simple enough. All you have to figure out is how many variables you have and how many equations can you write. Right? If the number of variables is less than the number of equations or greater than the number of equations, then of course you can't find those values. As simple as that. Okay, so that is all you have to do. If the charge Q2 is known, what you realize is what are the kind of equations that you can write. Okay. If the potentials are known, you can write the equation for this, write equation across here, equation across here, equation across here, and then you can also write an equation for all the charges. Summation of all the charges is 0. So you have 5 equations. 5 equations you could have written. And how many unknowns? You don't know the potential here. You don't know the potential here. You don't know the charges on 4 of the capacitor. So 6 unknowns. So since you can only write 5 equations and you have 6 unknowns, So no unknown can be found. Right? That's it. That's it. That is all that you have to think about. Now, if I give you any one of these, in fact, you would have been able to find all the rest of the variables. Okay. So that is it. That is it. Very simple. Do not get disturbed by this. Okay. This is not difficult at all. So with that, we have come to the end of today's session. Okay. So let's wrap it up. And before I wrap up today's session, let me just quickly remind you that if you haven't gotten your plus subscriptions and if you're planning to get your plus subscriptions, then these are the steps you need to follow. You can go to the plus section of your app, select your goal as IIT JEE and click on that get subscription button. And just after following these 3 steps, you would be redirected to the payment page where you will find a box that will say, do you have a code? So that is where you can enter this code RD Live. This code will give you a 10% off on all your subscription fees. Now you can choose from 2 kinds of subscriptions, Plus or Iconic. Now the fees of all these subscriptions are as mentioned here. And when you click on proceed to pay, you will realize that you can choose a lot of no cost EMI options to break these payments also into smaller parts so that you don't feel the burden of this payment. Now, those of you who don't know what the Iconic subscription is, let me quickly tell you about that. So the Iconic subscription is something that will take your IIT JEE preparation to the next level by allotting you personal coaches. So from our team of experts, you will be allotted personal coaches who will personally mentor you and guide you throughout your IIT JEE journey. And along with all the plus benefits, you also get to attend a lot of IIT JEE workshops, receive expert guidelines from time to time, get a study planner, and get regular test analysis sessions. So I think students who think that they need more individual attention should go for this subscription. And trust me, with all the benefits that you get with this subscription, definitely you will power through your IIT JEE journey. Next, the students who have just come into class 11th and are worried about how to go about their studies now, so they can definitely go for one of these combo subscriptions. So Unacademy now offers you 4 combo subscriptions, and these combo subscriptions take care of all your study needs, be it your IIT JEE preparation, be it your mains preparation, be it your advanced preparation, be it your CBSE 11th and CBSE 12th, and hence boards and school exams, everything taken care of by this combo subscription. So there are 4 combo subscriptions that you can choose from. First combo offers you the Iconic subscription for IIT JEE and the Plus subscription for 11th and 12th CBSE. This combo starts at 4,600 a month. And then you have the next combo, which offers you the Plus subscription for IIT JEE and the Plus subscription for CBSE 11th and 12th. And this combo starts at 5,500 a month. Finally, you have one combo which offers you the Plus subscription for IIT JEE and Plus subscription for CBSE 11th and 12th. This combo starts at roughly around 3,000, and the final combo, which offers you the Plus subscription for IIT JEE and the Iconic subscription for class 11th and 12th, will start at 3,900 a month. So depending on what you think you need to focus more on and where your study needs lie more, you can choose an appropriate combo subscription and then leave all your study worries behind. All right. So here, quickly, let me just also tell you the upcoming tests in January. So the Unacademy Combat, the last event for this month, is going to happen tomorrow, 31st of Jan. Make sure you're taking part in this. You can enroll using the code RD Live. Okay, and if you do well in this, you stand a chance to win yourself some really cool prizes. Apart from that, you also have AIM Advanced 2021 series happening every Saturday. Make sure you're taking part in that regularly, and then you have unique DPPs getting discussed every Monday to Thursday. Okay, so again, these will definitely help you prepare for your 2021 advanced papers. Next, if you like today's session, do not forget to press that like button and share it with as many people as you can. So let more and more students benefit out of this free quality content provided to you through this channel. Okay, so we know not every student can afford those subscriptions. So again, we are ready to help as many people as we can through this channel. So, but now, if you are benefiting out of this channel, then please don't be selfish and share it with others also. Let others also benefit from the contents of this channel. Again, we want this quality education to reach as many students as possible. Okay, so share it as much as you can. If you're new to this channel, don't forget to subscribe to the channel and don't forget to press the bell icon. Okay. All right. Now, the students who are following us on the JEE English channel of YouTube, do not forget to connect with us on the Telegram app using this link. So a lot of times students do subscribe to the channel, do click on that bell icon, still do not receive timely notifications. So I have had a lot of students complaining that, sir, we have done everything, but we still do not get any timely notifications, and because of which we have missed certain sessions. So again, there is a simple solution to that. You can join us on the Telegram group. On this Telegram group, all important information would be shared with you about every session and every lecture happening on this particular channel and every upcoming session. Also, other relevant information would be shared with you. Which reminds me, you might also want to check out the description box below. That also contains a lot of useful links about all the new batches that are coming up on Unacademy, and everything new that you need to know about. Okay, next, so that is it for today. I think this is where we would wrap it up. Now, before I leave you, finally, let me remind you, you have this amazing code RD Live. This gives you multiple benefits. So the first benefit is you can unlock the free features of the Unacademy app using this code. Features of Unacademy app using this code. Second, you can use this code to get a 10% off on your Plus and Iconic subscriptions. And finally, you can also enroll in events, in UA events like the Unacademy Combat and other such examinations. Okay. So one code, any uses. So do not forget to use this anytime you are in need of code. Right. So with that, let's take your leave. I will see you next with this series. I think maybe next Saturday, maybe not. I think it's getting very close to your IIT JEE mains. So maybe I'll give this series a little bit of break for a while, and we'll see what we can do. Okay. So I'll see you soon. Till then, you guys keep studying hard, keep practicing hard, and take good care of yourselves. Bye bye.